Bismillah ar-Rahman ar-Rahim. So today, inshallah, we're going to discuss the next chapter in our course, which is about the stability analysis. So from the previous chapters, here in the theory and the practical, we have been discussing the poles and the zeros, and we have said that a very important parameter that we can know about from the poles of the system is to be able to tell whether the system is going to be stable or not, right? So you can see here that the locations of the poles of the system indicate the response of the system. So if the poles are located on the left hand side, basically if all the poles are negative, it will mean that the system will be a stable system. However, if the poles are on the right hand side, the system is going to be unstable, right? And if the poles are located on the j omega axis, so the system is going to be marginally stable. So it is on the margin, the edge between the stability and instability, right? So this is summarized in this figure. We can see that, in these cases, you can see here I have a single pole and it is in the left hand side. So if I have a single pole on the left hand side and it does not have any imaginary component, so j omega is equal to 0. Omega here is equal to 0. Omega equal to 0 means that the system is not going to oscillate, so there's no oscillations. And because the pole is on the left hand side, that means that the response is going to be decaying like this, right? So you can see as the time goes on, as the time increases, what happens to the response? It decreases like that. Okay, it decreases exponentially, because if I have a pole in this location, if I have a pole, and for example, if this pole is -2, here, if the pole is -2, it means that the response it means that this, the pole located, or the term associated with this term is going to be s plus 2, right? Yani s minus 2. And this one, when I get the Laplace transform, is going to be e minus 2t, right? So the response of this pole is e minus 2t. So it will decay like that, right? So, and you can see I don't have any oscillations in this case. What happens if I have poles on the left hand side, but now I have a j omega term, so omega is not equal to 0. So what's the difference? The difference is that, yes, the system is going to decay as well, but in addition, I'm going to have two conjugate poles like that. So this one, for example, is at this particular one, for example, is -2 plus j2, and this one is going to be -2 minus j2. Okay. So now I have j omega. Omega here is equal to 2, right? So this means that in the response, I'm going to have these oscillations. Okay. So here I'm going to have two poles. And why do I have these oscillations? Because as you have seen, that if I have two imaginary poles, I'm going to get something like that. I'm going to get e minus 2t, but this is going to be multiplied by a cosine, right? Cosine 2t, right? And of course, going to be multiplied by a constant here. Okay, that's why I have these oscillations like that. Right. What happens if I have two? And of course, since I have this pole, I'm always going to have this conjugate right here, right? So if I have a pole, I'm always going to get it's going to conjugate, right? Like, what happens if I have two poles on the j omega axis like that? If they are exactly on the j omega axis, then it means that the system is purely oscillating, right? I don't have any damping factor, right? It's neither growing nor decaying, but instead the system will continuously oscillate at a fixed amplitude. So in this case, the response is going to be cosine omega t, right? So it will oscillate with this omega, whatever omega here is. If omega here is equal to j2, if omega here is equal to 2, then it will oscillate with a frequency of 2 radians per second. So this is going to be my response. The signal is going to look like that. Okay, in this case we call it, so these two we call them stable. So the system is stable in both these cases, because regardless of how how long the system will go on for, it will never blow up. So we call it a stable system, right? This particular case, it is at the edge, right? At the edge of the circuit. If it goes a little bit to the right, it becomes unstable. If it goes a little bit to the left, it becomes stable. So this particular case, and even this one, these two, we call them marginally stable. Marginally. Margin means the edge. Okay, so these are the edge, at the edge of stability. Marginally stable. Okay, type this in this case similar to this one, but with the difference is in this case I don't have j omega, I don't have oscillations, so the omega here is actually equal to 0, right? So I don't have the real part is equal to 0 and the imaginary part also is equal to 0. The real part equal to 0 means what? It means it's not going to increase or decrease. It's neither going to grow or decay. The imaginary part means equal to 0 means I don't have oscillations. So this basically I get a DC basically kind of response like that. Okay, so the constant here I'm going to have H just a constant. I'm going to have a constant depends on the amplitude. The amplitude that's multiplied by this particular gain. So the associated pole for this one could be, for example, 5 over S. The associated term with this pole is going to be 5 over S. In this case, the amplitude here is going to be H is going to be equal to 5. Okay, and we know that 1 over S gives us H, gives us constant, right? From the Laplace transform table, we know that 1 over S gives us this constant because of this relationship that we see here. So again, these two are called marginally stable. Actually, we have like a caveat here we have to be careful with. In this case that you see here, these poles are not repeated. We call them simple poles. We'll look at that in the next slide, inshallah. But if these poles are repeated, then the system is not marginally stable. The system is going to be stable, unstable actually. So I have here a caveat, an asterisk. I have to be careful. If these two poles are repeated, then the system is unstable. Fine. Now these two are the opposite to this one. Right here in the first one, I have a pole on the right hand side without oscillations. So j omega is equal to 0. Omega is equal to 0. That's why I don't have oscillations, but the system is negatively damped, so it will grow up like that. It will increase, it will blow up like that. So obviously this is unstable, right? Similarly, this one is also unstable, but it grows, it increases with these oscillations, because here I have an H, I have an omega part. So omega here is not equal to 0 anymore, so it will oscillate with this particular omega. If omega is equal to 3, this will oscillate with a frequency of 3 radian per second. So these cases are H unstable. Okay, and of course stability is extremely important in the system, because we want the system to operate within, we don't want the system to blow up, right? So instability examples, as we have discussed before, for example, if you have, for example, an electronic circuit like an operational amplifier, an op-amp, right? So operational amplifiers are actually very susceptible to instability if you don't take the required countermeasures to prevent this instability, because you have so many transistors inside the op-amp, and each transistor can is associated with one or two poles, right? So having these large number of poles, like an op-amp, for example, you have between 20 to 30 transistors. So you can imagine you have a huge number of poles, so it is very easy for the system to become unstable. Okay, if the op-amp becomes unstable, what happens? So instead of amplifying the voltage, which is the job of the op-amp, it will act like an oscillator. So it will basically it will generate an edge of voltage out of nowhere. Not out of nowhere, it will generate a signal even if you're not supplying a voltage. So regardless of what you're supplying at the input, it will create a signal from the output side. But it's not out of nowhere, because and it is using the energy coming from VCC, from the biasing supply DC voltage. Instability in power systems. For example, if you have a system, you have several generators that are working in synchronism. So if you have, for example, any fault, short circuit at any point in the circuit, any type of faults, so if you don't clear these faults fast enough, then the generators are going to become unstable and they are going to be driven out of synchronism. So the system is not going to be synchronized anymore. And this is the case because in most cases, like synchronous generators are used in power systems. طيب. So when we talk about stability, we are particularly talking about what the so-called BIBO stability. BIBO is short for bounded input, bounded output. What does that mean? It means that if you give me a bounded input, a bounded input means that the input is limited, it's not infinity basically. So if the input is not infinity, the output also should not be infinity. So if you give me anything that's not infinite, then the output should not go to infinity. This is called stable or bibostable. Bibostable. On the other hand, unstable systems, if you have instability in the system, even if you give not infinite input, so even if your input is not infinite, you can have actually infinity at the output. It will grow to infinity like that. It will blow up. Okay, so this is the type of stability that you are talking about. It's called the BIBO stability. So you can see here for BIBO stability, the roots of the characteristic equation must lie in the left half plane, right? So characteristic equation, we talked about it last week in last week's lecture. So the characteristic equation is basically the denominator of the transfer function. So you take the denominator of the transfer function, you equate it to 0. This is your characteristic equation. If you solve the characteristic equation, what do you get? You get the poles of the system, right? The eigenvalues or the poles of the system, right? So in order for the system to become stable, all the poles must be lying on the left-hand side plane. And if they are lying on the omega axis at half, then the system is marginally stable. Okay? Yeah. So we have these examples in front of us. We have these systems described by these transfer functions. So if I look at the first system right here, what are the poles of this system? I have 3 poles. So this system has 3 poles. What are the poles? They are -1, -2, -3. So all of them are simple negative poles. So if this is the case, then the system is going to be stable, bibostable. We can just say stable. And it does not have oscillations. Why doesn't it have oscillations? Because I don't have a j omega component here. So omega is equal to 0 means there's no oscillations, right? The next system that I have here, what are the zeros? So, and the zeros here we don't care about the zeros. Again, the stability is decided by the characteristic equation. I'm only interested in the characteristic equation, المقام. So this system, I have a 0 at -1, but I don't care about the 0. I only care about the poles, right? So right off the bat, I can see that I have a pole at +1. So I don't even need to open this bracket, to open this, because even if only one pole is in the is a positive right hand plane like this one, then the system is going to be unstable. So this is unstable because of this pole. Like, how about this one? I have a pole at -2, but opening this one up, in this case, what are the poles? I have 2 poles. One of them at +J2, and the other one is -J2. So this one is giving me 2 imaginary poles, right? 2 imaginary poles. But you can see that these poles are located in the j omega axis. Why? Because I don't have a real part here. I only have imaginary part. So having imaginary part, if this is the case like that, I have plus and minus j omega 2. So I have plus minus j omega 2. So this will make when I have negative and I have something on the j omega axis. So having something on the j omega axis will make it marginally stable. So I have here marginally stable. Now this is similar. Here I have a pole at -10, and here look, this term اللي طلع لي plus minus j omega 2, it is actually repeated here. I have square. So I have, how many poles do I have in this system? I actually have 5 poles. 5 poles. I have -10, this one. I have J2 minus J2, and then I have J2 again minus J2. You can see that these poles are repeated. These poles are repeated. So we call these repeated poles, not simple poles. Now in this case, having J omega part like this, in this case, having something on the J omega axis, if it is simple pole like this one, then the system is marginally stable. Lakin if it is repeated, even if it is here, so I have something here like here it's repeated like that, J2 repeated. Here I have minus J2 minus J2. So if you have something repeated on the J omega axis, you get ايش? Actually it becomes unstable. So this is the caveat that we talked about in the previous slide. So you have to be careful. If the J omega part, it's not J omega, this is not applicable if it is lying here. يعني if the poles are repeated here, ما في مشكلة, still stable. Okay, even if they're repeated like 5 times, I don't care. The only case you have to be careful with, if the poles are in the J omega axis. If they are repeated, then it's unstable. It's not. If it's simple, if it's only once, it's not repeated, it's only once like this case, then the system is marginally stable. That's why I call it marginally, because it is in the edge, at half. So you can see that from the previous slide, we have seen that to determine the stability of the feedback control system, we're all interested in the roots of the characteristic equation. هي المقام. هذا مقام الإيش. So if I have a system like that, what is the transfer function? The transfer function is g over 1 plus gh. So I'm only interested in this, equal to 0 of course, because it's an equation, right? So I'm only interested in this. This will tell me about the stability. I don't care about the numerator. I only care about the denominator. But in order to be able to tell this, and in this case, what did we do? All you have to do is just look at the poles. Left hand side means stable, right hand side unstable. But the issue is that most transfer functions are not actually given like that. They are not actually given in zeros on poles form. Right? They are actually given in polynomials. As you are going to see now. So if I have a polynomial, if it is a quadratic equation, if it is a second order polynomial, then it's easy. If it's a second order equation, an s square, it's easy. I can just apply the quadratic equation to find the roots, find the solutions, find the poles. But in most cases, like in higher order systems, if you have s cube, s to power 4, s to power 5. So in these cases, you don't have an equation you can just apply to know what are the poles. And in real life systems, the order of the system can be huge, right? You can have 10th order, 20th order, 500th order. So it becomes almost impossible to factorize the denominator to get the poles of the system. Okay, so this is the challenge, right? It's not always, in most cases, it's not easy. It's difficult to obtain the poles of the system. So it is difficult to talk about the stability of the system. So that's why there are some techniques, algorithms, like this one that we're going to be studying now. It's called the Routh-Hurwitz stability criterion. So these techniques, on this technique, for example, I don't need to know what are the poles. So we're not going to find the poles of the system. Okay, we're not going to find the poles of the system. But this technique, it will tell us if there is any poles on the right hand plane or not. Do I have any positive poles or not? This is what this technique is going to tell me. It will tell me, do I have any poles on the right hand plane or not? If I have any poles on the right hand plane, معناها ايش؟ Unstable. If I don't, معناها stable. Simple as that. So if I'm only interested about the stability, this technique tells me about the stability of the system. Whether the system is stable or not. So applying this technique will tell me whether the system is stable or not. Okay? So this technique actually will tell me two things. أول شيء, do I have any poles on the right hand plane? If I have any poles on the right hand plane, معناها خلاص, unstable. Additionally, it will tell me also how many poles do I have on the right hand plane. It will tell me how many do I have. So it will tell me whether I have or not, and how many do I have. So in this slide, this is basically like the algorithm of the steps to apply the criteria, the technique. So instead of just going through these steps, it's better always to dive into the examples. So this is exactly what you are going to be doing now. We're going to be going to the examples right away. So we'll just dive into the examples and explain on the examples themselves. We actually here have different cases. We have 4 cases to be particular. We have 4 cases we need to discuss. Okay. So yeah, this is actually a mistake here. These all are powers. معناها ايش؟ Now look, let's just get this out of the way, then I'm going to explain it. The first case is no element in the first column is 0. We'll see what this means. Okay, we'll see what this case means. Now let's read the example together. It says determine whether any of the roots of the characteristic equation. So this is the characteristic equation. Okay, he didn't even give me the transfer function. Okay, all I need to determine the stability is just to look at the characteristic equation. So he's telling me if this is the characteristic equation, then is there any poles are in the RHP? RHP means what? Right hand plane. Here, yeah. Do I have anything here on the right hand plane or not? If I have anything on the right hand plane, معناها ايش? Unstable. Okay, so let's see how I apply this technique. So I'm going to just copy the equation here, the characteristic equation. What does it say? It says s to the power of 6 plus 4, s to the power of 5 plus 3, s to the power of 4 plus 2, s to the power of 3 plus s squared plus 4, s plus 4 equal to 0. Okay. Now pay attention, شباب. Okay. So the technique is very simple. Okay, if you just focus once, you can get it and خلاص. So the Routh-Hurwitz criterion is based on something that is called the Routh-Hurwitz array or table. So we're going to build a table or an array here. This array is going to tell us whether the system is stable or not. So how do I start? So I will look at this. This is s to the power of 6, right? So I'll go here. I will write s6, s5, s4, s3, s2, s1. So I'm just listing Ash starter from here going to S1 and actually I'll go to S0 as well. Okay, let's see. Okay, so I'll have a table like that. See, I'll have a table like this. Then I will come here. I will fill these 2 rows, right? I will start by filling these 2 rows using the coefficients of these terms. So look, this is S6, so I'll go like that. S6, what is the coefficient here? 1, right? So I'll write here 1. Now the tricky part here, or the only thing that you have to be careful with is the way that you move in the array is actually like that. You don't move like this or move like that. لا, you move like this. See? I will move in this shape, like this zigzag shape. فببدأ here. See, S5 بحط 1. Now S6, sorry, 1. How about S5? I have 4. So I go to S5 here. I'll put H 4 like that. Okay, and then the next term I will move here again, as we said. So I'll start by this, go down, then go up here. What's the next number? 3. So I'll put 3. What's the next number? 2. So I'll put 2. What's the next number? It's 1. What's the next number? It's 4. So I'll put 4 here. What's the next number? 4. So this is how I move, Yashma. I move like that. So I'll move like that, and I just put the coefficients of the characteristic equation like this. Okay, so this is how you fill the first 2 rows. Okay, and then I'm going to start filling the other elements in this table. How am I going to fill? What's the element that I should be here? If it's empty space, it means it's 0. It means here I have a 0. Okay, now how do I fill these elements that I have here? So pay attention, Shah. I will start here first. So we are going to do it in a similar way to the way that we find the determinant of a matrix. Remember how do I define the determinant of a matrix? I multiply this by this minus this by this, right? Now we'll do the opposite, we'll reverse it. So I will do this multiplied by this minus this multiplied by this. See, it's the opposite. هذا ضرب هذا. وهذا مع إشارة إيش سالب. So the negative is not here, the negative is actually here. Not only that, and then I'm going to divide by this number. See? The above, so I'm doing this place, right? فباخذ الخانة اللي فوقها وأقسم عليها. So I'll divide by this number. So this place that I have here is going to be what? It's going to be 3 multiplied by 4 minus 1 multiplied by 2. Again, هذا minus هذا ضرب هذا. عكس determinant. And then all of that divide by الخانة اللي فوقها اللي هي كم؟ اللي هي 4. So what does that give me? I have 3 multiplied by 4, I have 12 minus 2, 10. 10 divided by 4, I get إيش؟ 2.5. Right? 2.5. So this in this position I have 2.5. Now let's do this place here. How am I going to do it? Be careful. I'm doing this row, right? I'm always going to be started from these two. These two are fixed. The first column هذا هو أهم column عندي. This column is the most important column. So it will always be fixed. So in order to get this one, إيش بسوي? These are fixed. And instead of taking these two, I will go to these. So look, I will do something like that. See? As if I stretched. شفت ال X? Look at this X that I had here. Now I stretch it like that. Stretch it out like this. And I do exactly the same. So what do? I do, again, just 4 multiplied by 1. 4 multiplied by 1 minus 4 multiplied by 1. So minus 4 multiplied by 1. Divided by ايش? Then divide by this. So this is like a pivot. تعال نسميها pivot. Like المحور, okay? So I'm always going to be divided by this one. I'm always going to be dividing by this number. في الصف هذا I'm always going to be dividing by that. طبعا this is equal to, this is 4 minus 4, so this will give me ايش? 0. طيب, how do you guess I am going to get this one? This element? It is going to be, again, stretch this like that. So it will be 4 multiplied by 4 minus 0 multiplied by 1. So 4 multiplied by 4 minus 0. Divided by ايش? 4 multiplied by 4 minus 0 divided by 4. So what do I get? I get 1. So this gives me 1. طيب, how about this? خلاص, this will be ايش? If I want to get this value here, what do? I will have to multiply 4 multiplied by 0. الخانة اللي هنا ايش? 0 minus 0 multiplied by 1. So 0 minus 0, so I get ايش? 0. So I can put 0, just leave it ايش? Just leave it as an empty space. Okay? طيب. Oh, sorry, sure. 4 multiplied by 4 is 16 divided by 4. Should be 16 divided by 4, so you get 4 here. This should be 4, not 1. So these are the ايش? These are the elements that we just obtained. Okay, 2.5, 0, and 4. Okay, so this is how we get the first row. Now we move to the next row here. طيب, how do I do this one? I will follow similar technique, but so you can see that when I was filling this row, what did I do? I took these first, these two. يعني لما أعبي, when I fill this row, I will take the two above them. I'll take these two, the ones that above this row. Now, if I'm going to do this row, which two should I take? I will take these two. صح؟ باخذ الاثنين اللي فوق على طول, هذا وهذا. بالقيم اللي ايش? Using the values that I just obtained. So in order to get this value, what do? I will take 2.5 مع 2 and 0 مع 4. Okay, x like that. Okay. So remember, it's you have to do it the opposite way to the way that you do the way you do the determinant. Okay, so it will be 2 multiplied by 2.5 gives us 5 minus 4 multiplied by 0, so 0. So it is 2.5 multiplied by 2 minus 0 divided by divided by 2.5. So what do I get here? I get 2. So here I have 2. طيب, how about this element اللي عندي هنا الخانة هذه? How do I get this element here? this element is going to be, again, I'm always going to be using this issue and stretch. Okay, so I'm not going to use the 2.5 2 now. I'm going to use 2.5 مع الايش مع 4 like that. Okay, and then I'm going to use the 4 هذا مع الايش مع 4 like that. So I'm taking these. So it will be 4 multiplied by 2.5 minus 4 multiplied by 4 and divide by ايش 2.5. I'm always going to be dividing by 2.5 and dividing by 2.5. So if you actually use the calculator to find this one will give us ايش 4 multiplied by this will give us 10. 10 minus let me just 4 multiplied by 2.5 minus 16 divided by 2.5 we get minus 2.4. Let me just make sure it's the correct value that you have here or not. Yeah, so minus 2.4. Yeah, so here we have minus 2.4. طبعا in the solution يا شباب we don't have to put like this, and I'm just putting these like these expressions to show you what we are doing. But as you are going to see in the next examples, we're just going to put the answer right away. It will make it cleaner and easier to do, and you can use the calculator to put the expression and find whatever you like. Right, now let's move to this one. Now this one, what do you think is going to be? I'm going to multiply 2.5 multiplied by 0. Stretch it now more to here. 2.5 multiplied by 0 minus 0 multiplied by 4. So it's going to be just 0. And of course, if you have any 0 you have here, معنى all the elements below it, they're automatically going to be 0. معنى هنا this will be 0 also. The next one هذا بيكون 0. And these are going to be 0. So 0, 0 like that. Now we move to s square. Now which 2 do I take? I take these 2. Take the 2 directly above it. So in order to get this one, what do I do? This one will be 2 multiplied by 0. 2 multiplied by 0. هذا ضرب هذا. Minus this multiplied by this. So minus 2.5 multiplied by minus 2.4. هذا ضرب هذا. صح؟ divided by ايش؟ what do you think? What should I divide by? I'm going to divide by the ايش؟ الخانة اللي فوقها على طول. هذا. The first element in the above row. اللي هي 2 هنا. So I'm going to divide by 2. So how much this do this with the calculator? So you can see 2.5 multiplied by minus 2.4 divided by 2. So this gives us ايش؟ minus 3. So here I have minus 3. Okay, how about this element? How do I get this one? I will take 2 with the 4, go like this. So 2 multiplied by 4 minus ايش؟ minus 0 multiplied by 2.5 يعني minus 0 divided by ايش؟ divided by 2. ف 2 will cancel with the 2, I get ايش؟ get 4. So this observation, this behavior يا شباب, we are going to see it يعني whenever we have 0 like that. شوف أنا عندي 0 هنا, يعني هذا ضرب هذا ناقص 0, automatically I can put this value, put it here. ليش؟ لأنها دائما بتكون إيش؟ It will always be like this multiplied by this minus 0 divided by this. So this will always cancel with itself. معناها الخانة هذه على طول تقدر تحطها هنا. Or just do it, just be the safe side and just do it. And of course this, what should I put here? Automatically put 0. Because it's h, it's 2 multiplied by 0 minus 0 multiplied by this. So 0 minus 0, you get 0. And again, if this is 0, this will always be 0. Now let's go to the next one. How do I get this one? I will get this one, I'll multiply this by this. So it's minus 3 multiplied by, look يا شباب لاحظ, شوف, minus 3 multiplied by that. Minus 3 multiplied by minus 2.4. بعدين ايش? Minus this multiplied by this, right? Minus 2 multiplied by 4. What should I divide by? Divide by this, اللي فوق. So divide by minus 3. How much does this give me? So you have minus 3 multiplied by 2.4. Sorry, minus here, I have minus also. minus 2 multiplied by 4 divided by minus 3. What do I get? I get 4 over 15. Let me just make sure if this is correct or not. So minus 3 multiplied by minus 2.4 minus 4 multiplied by 2 divided by minus 3, 4 over 15. Let me just double check. So this is minus 3. Oh, this should be plus 3, not minus 3. So let's double check on this one. So 2 multiplied by yeah, in order to get this one is 2 multiplied by 0 minus 2.4 multiplied by 2.5. Okay, let me just double check on this again. 0 minus 2.5 minus 2.4 divided by 2. Yeah, this should be plus 3. Yeah, this should be plus 3. I had a mistake here, issue. So here this should be plus 3 like this. Fine. Now let's go back again to this one. Okay, so yeah, so we get minus 76 over 15. Okay. Next we have this element that we are going to put here. So what is this element? This element is going to be this. It's going to be this multiplied by 0 minus this multiplied by 0. So it's going to be just going to be 0. Right, so this multiplied by 0, 0 minus 0 multiplied by this 0 divided by 3, we get 0. So it's 0. And of course this is 0, this is 0, this is 0. So what is the last element that I'm going to have here? It will be this multiplied by 4 minus 0 divided by this. فايش بيبقى معي؟ بيبقى معي 4. Okay? And of course all the others are 0, 0, 0, 0. Okay? So this is how we fill the Routh-Harris table. In the next example, inshallah, I'm going to do it we'll do it in a cleaner way. So I'm going to use the calculator instead of writing this, so it will be cleaner and easier to follow with, inshallah. But I just wanted to put this equation to show what is the process to find these elements. And look here, sharp. Always the last element that I'm going to have here down here, the one that was with S0, it should always be like equal to this. So if this is 4, then this has to be 4. So this can tell you whether your steps are correct or not. You should always get the same constant here. This should be your constant of the characteristic equation. You should get it always here. طيب. خلاص, now we filled the Routh-Harris table. Now we need to decide, is the system stable or not? So remember we said that this technique is going to tell me whether the system is stable or not. In addition, it will tell me whether it will tell me the number of poles I have on the right hand plane. So how I'm going to do that? In order to do that, I will go to this column, first column. This is the most important one. Then what do? I will look at the signs, إشارات. I will write it here. What is the sign? What is the element here? It's 1, and a positive. How about this one? It's 1, it's positive. How about this? 2.5, positive. How about this? 2, positive. How about this? Plus 3, positive. How about this? Minus 76 over 15, negative. How about this? 4, it's positive. Okay, so now I'm writing the sign of each element in the first column here. So what does the Routh-Harris criterion say? It says that the number of poles on the right hand plane, is equal to what? It is equal to the number of changes in the sign. يعني it's equal to عدد مرات تغير الإشارة. Look, positive, موجب, still the sign is the same. Positive, the same. positive, the same, positive, the same, positive, the same, negative. I have a change here. Look, I change from positive to negative. So here, this means I have the first pole. Means now I have a pole on the right hand plane. Man, automatically, if I have this, man, automatically the system is ايش? Unstable. خلاص, I know it's unstable. If I have a change in the sign in this column, positive to negative or negative to positive, then ايش? The system is unstable. طب the number of poles on the right hand plane يعتمد على ايش؟ The number of change in the sign. I change from positive to negative. This is the first pole, and then I'm changing from negative to positive. This is another change. Negative to positive. This is the second pole. It means I have two poles on the right hand plane. I have two poles on the right hand plane. Okay, so if I go back here to our slide. Okay, so it says that based on this, since I have positive to negative, the negative to positive, then I have two roots on the right hand plane. But what are these two roots? كم قيمتهم? What are the values of these two roots? I don't care. This is not the job of this technique. And we don't even need to know them. We only need to know if they're positive or they're on the right, on the left hand plane. Just because this is the only information I need to know in order to tell about the stability of the system. طيب, if you use MATLAB عشان تأكد in order to verify if this is true or not, you can use MATLAB. So if you use MATLAB to find the roots of this characteristic equation, it will tell you these are the ايش. طبعا of course this is a sixth order system. It means how many poles I'm going to have? I'm going to have 6 poles, and these are the 6 poles. لاحظ, this is on the left كلهم negative, negative real part, negative real part, negative real part, negative real part. So these poles I don't have issues with them. I have an issue with ايش, with these two poles. Why? Because they are ايش, they have positive real parts. معناها they are on the right hand plane. They are here. معناها ايش? Unstable. Because they have two poles on the right hand plane. طبعا the technique does not tell you this. The technique خلاص tells you only have two. هذا in order to verify عشان تأكد. فعلا MATLAB tells us indeed I have two poles on the right hand plane, and indeed the system is going to be unstable. طيب, let's do another example. Okay, so you can look. I have this first order control system. Okay. This is another way where the questions can come on this technique. Okay. I have this control system. لاحظ, what is the question? The question is asking, determine the range of k that will make the system stable. Now I have a controller here. Now, in this case, of course, it's a proportional controller. So this is the gain. This is the gain k. I can put any value here. Now some values are going to make the system stable. Some values are going to make the system unstable. Just like we saw in the PID experiment in the practical, right? So he's asking us here. Us about what? He's asking us find what is the range of the values that make the system stable and unstable. So how do I do that? In order to know this, what do I need to do? I need to get the characteristic equation. انتبه, don't take this. This is not the characteristic equation of the system. And these are not the poles of the system. These are the poles of what? minus 0 والplus 6 والminus 1 are what يا شباب؟ السيستم هذا لحاله, if I take it as it is without a controller, it's unstable, right? ليش? Because I have a pole at plus 1. فالplant is unstable without a controller. Having this controller in this feedback loop, I can actually make it become stable, but I have to choose the correct value of k. فالغرض من الquestion هذا is what is the range of the values of k that I should put here to make the plant or to make the process here stable. So in order to do that, I can apply the Routh-Harris criterion. But the Routh-Harris criterion applies on the characteristic equation. So it means that the first step that they have to do is to obtain the characteristic equation of the system. So before we start this job, we have a mistake here actually. This should be s plus 1. This should be s plus 1. It's not actually s. Okay, so fix this one please. This should be s plus 1. Otherwise the s would have cancelled with this, right? طيب. So again, the system here is unstable. The process itself alone is unstable. Why is it unstable? Because here I have a pole at plus 1. Now having the controller here with the proper value, proper gains can make the system stable. So in order to know whether the system is unstable or not, I need to first get the characteristic equation, right? So what is the transfer function? The transfer function here is going to be y over r. I don't care about the transfer function. So I'm going to have something up here. I don't care about it. Which is going to be basically this multiplied by that, right? The forward path. Divided by h1 plus, because I have a minus here, negative feedback. H this multiplied by the feedback transfer function, which is equal to 1 in this case, because it's unity feedback. So plus h here I have k, s plus 1, s plus 6, s minus 1. Right, now what is the characteristic equation? The characteristic equation of this system is 1 plus k, s plus 1, s plus 6, s minus 1 equals to 0. This is my characteristic equation. Now, this is not a polynomial, proper polynomial form, so I need to write it in a polynomial form. How can I write it in a polynomial form? I can multiply both sides of the equation by the denominator here عشان أتخلص من المقام هذا. So I multiply everything by this. So multiply everything by this. Multiply everything by this. So if I do that, what happens? If I multiply by 1, so I get h, I get here s plus 6, s minus 1, s minus 1 plus k s plus 1 equals to 0. Now open this one up and open this up again. So if I multiply these together, what do I get? I get s square مع s اللي برا, so I get s cube. Then minus 6 minus 1 مع 6 minus 6 مع s هذه, so you get ايش? Minus 6s. And in the middle, what do I have? I have s square. I have minus s هذا مع هذا minus s plus 6s, so you get ايش? Minus 5s. Right, but I have s outside, so it will become s square. Then plus ايش? Multiply this by this, what do you get? You get ks, then plus k equals to 0. Now you can see here I can take s as a common factor here, so what do I get? I get s cube minus 5s square minus, can put here plus s. So what do I get if I put plus s? I get k minus 6 plus k equal to 0. I just took an s as a common factor outside, so you get k minus 6. Right. Now, in order to know what is the range of the values of k that will make the system stable, and I'm going to apply the Routh-Howard criterion. This is a third order system, so I'll start by s cube, s square, s1, s0. Right? Bring it up a little bit. Right. Now start by filling up these two rows. So how do I start? I have 1, then minus 5. I think we made a mistake here. Let me just, yeah, this should be plus 5. This should be plus 5-ish. Plus 5, right? Because you have 6s minus 1, should be plus 5s squared. 6 minus 1, yeah. Plus 5, then 1, 5. What do I have here? I have k minus 6, then k, right? 1, then 5. Then the coefficient of s, what is the coefficient of s? It's k minus 6 as a whole, put it like that. And then k. طيب. What is the element that I have here? It will be what? It will be 5 multiplied by this. It will be 5 minus half, right? Minus. So 5 multiplied by k minus 6 divided by h. Sorry, minus minus h minus, here I have h minus k divided by 5. How about here? It's 5 multiplied by 0 minus 0 multiplied by 1 divided by 5. It's 0. I don't have anything here. So you have this term like that. How about the term that I have here? It's equal to h. It's equal to this big thing multiplied by k minus 0 multiplied by 5 divided by the same thing itself. So what do I get? I get k. Again, this multiplied by k minus 0 خلاص معناها باقي I only have ايش هذا multiplied by this multiplied by this divide by this, so you get this, you get k. And since this the constant here is k, then I'm getting here a constant, means our what you are doing is correct. Now remember, what's the question? The question is asking us about the range of k. What is the range? What are the values of k that will make the system stable? لاحظ, this is positive, this is positive, k is unknown. Here I also have k. When is the system going to be stable? The system is going to be stable if all of these elements are positive. Do you agree? Because if all these elements are positive, معناها ما عندي تغير. I don't have a change in the signs. معناها ما في, I don't have any pause on the right hand plane. معناها I need all of these to be positive. This is already positive. This is already positive. Positive, positive. So I need now to choose I need to know what are the values of k that will make this positive and also this positive. Okay? طيب. Let's start with this one. This is simple k. So in order for this component to be positive, what should I do? This will make, I need for this will necessitate that k has to be greater than 0. If I make k greater than 0 خلاص this is positive. معناها ما عندي مشكلة هنا. لكن if you look carefully, if I choose for example k equal to 1 and I put it here, what will happen? I will get 1 minus 5, sorry 1 minus 6 minus 5. Minus 5 multiplied by 5 minus 25. Minus 1 minus 24 divided by 5 minus 24 by 5. So it's negative. So if I choose k equal to greater than 0, yes, it's solving this. But it's not necessarily it's not necessarily going to make this equal to a positive number as well. I need to test, I need to look what are the values of k that will make this positive. So I need this whole thing, I need all of this, I can come here like that. I need 5 multiplied by k minus 6 minus k divided by 5. I need all of that to be greater than 0. Well, I become positive. I need this thing as a whole, all of it to become positive. Okay? Now in order for this to become positive, I only need the numerator to be positive. I don't have to worry about 5 هذه. So I can just ignore it. Or just multiply both sides by 5 and 5 be cancelled. This is called an equality يا شباب. An inequality. طيب, so I need to solve this thing basically. So what do I do? Multiply both sides by 5. So what do I get? I get, and I can insert the 5 on the parentheses. So I get 5k minus 30. وعندي هنا k برا minus k. خلاص وال5 هذا I can just ignore it. Greater than greater than 0. Right? معناها this 5 minus k becomes then I have 4k 5k minus k 4k minus 30 هذه I can take it to the other side. So 4k has to be greater than, طبعا when I move to the other side I have to reverse the sign here, the polarity. So it will become plus 30. Then divide both sides by 4. معناها k has to be greater than 7.5. معناها for this term to be positive, k have to be greater than 7.5. For this term to be positive, k has to be greater than 0. معناها if I want to answer the question, for this, if I go back to this controller, this proportional controller, what should I use? Should I use just any value above 0? Or should I use the value that has to be greater than 7.5? This actually has to be greater than 7.5 because this will satisfy both conditions. If I choose anything above 7.5, this will be positive, this will be positive. لكن لو اخترت مثلا k equal to 1 or 2 or 3 or 4 or 5, anything below 7.5, صح هذا بيصير positive, but this will be this will still be negative. So it will not solve my issue. So the range of k is k has to be greater than 7.5. K has to be greater than 7.5. Okay, k has to be greater than 7.5 in order to make the system stable with the controller. Right, let's move to the next example. So case 2 is saying that in the first case يا شباب, case number 1 is saying that no element in the first column is 0. And all elements اللي هنا they are not 0, non-zero numbers. In this case we're going to see actually if I have a 0, what should I do? Yeah, let's look at the characteristic equation. So this is the characteristic equation that I have here. So let's try to apply the Rath-Hurwitz criterion and see what we are going to end up with. So we have s to the power of 5 plus 3 s4 plus 2 s cubed plus 6 s squared plus 6s plus 9 equals to 0. So we start s to the power of 5, s4, s3, s2, s1, s0. I'll put these values here according to the coefficients. So 1, then 3, then let me give myself some space, 2, then 6, then 6, then 9. Okay. What should I have here? It should be 3 multiplied by 2, 6. 6 minus 6 ايش 0. So I have here now I have an issue here. Here I have a 0. Right? So 6 minus 6 0. طيب, how about this element? That's 3 multiplied by 6. I get 18 minus 9. So 9 divided by 3 is 3. How about this element? It's 3 multiplied by 0 minus 0 0, so it will be 0. طيب, now let's see what's going to be the issue. If I try now to obtain this element, how do I get this one? It will be ايش? It will be 0 minus multiplied by 6, 0. Minus 3 multiplied by 3, so it's minus 9. Then divided by ايش? Divided by 0. So basically this element will be like minus 9 divided by 0. So I cannot divide by 0, as you know. So this is where the issue comes. So now I have the issue here. I don't know what to, I cannot just do it this way because I'm going to have 0 minus 9. So minus 9 divided by 0. So minus 9 by 0. It's, we don't know what that. We cannot find. We cannot divide by 0, right? So how do I solve this issue? We solve this issue by, instead of taking this as a 0, right? I'm going to replace it by an epsilon, a very small number. I'm going to replace 0 by epsilon. What's epsilon? Epsilon is a very small positive number. شوف, it's going to 0 from the positive side. So it's a very small positive, very small positive number. يعني مثلا 0.00001. Okay, and now I'm going to use that in the next rows. يعني let's go back here again. How do I find this? This will be equal to epsilon multiplied by 6, right? So it will be 6 multiplied by epsilon, right? Minus 3 multiplied by 3, so it's 9. Divided by I'm not going to divide by 0 now. I'm going to divide by this epsilon. Okay, now what do I do next? In the next step, I'm not going to leave this as it is, right? Now 6 multiplied by epsilon is how much? 6 multiplied by epsilon is how much? Remember, epsilon is a very small number. فأنت ممكن, you can come to the calculator. I can come to the calculator. I can, instead of epsilon, I can put a very small positive number. So look what I'm going to do. I'm going to put 6 multiplied by 0.0001 minus 9 divided by epsilon. What is epsilon? 0.001. Oh, sorry, I have a 0. More 0 here. Look at the number that I have here. It's a very large negative number. This is what I know. I want to know what's the sign. Remember, احنا في Rath-Hurwitz criterion we are interested in knowing the sign. Okay? طيب, if now this is the expression that I have. So I know this is a very large negative number. Okay? So I can put negative here. But before I do that, because remember, I need to still go to the next rows that I have here. So I cannot just leave this as it is. Now, this is a little bit complicated. I can actually simplify this. There are two ways to simplify it. I can either divide both sides by epsilon. فهذا بيصير ايش? 6 epsilon minus 6 epsilon divided by epsilon. What do I get? I get 6. صح? So 6 epsilon divided by epsilon. Epsilon cancel epsilon. I get 6. minus 9 divided by ايش؟ by epsilon. Another way to do it is actually to make this cancel. 6 minus 6 multiplied by epsilon is equal to what? So do it here. 6 multiplied by 0.0001. Look at ايش? Very small number. So you can actually just make it equal to 0. معنى هذا كله, all of this is equal to ايش? Is equal to minus 9 over epsilon. Okay, so this is equal to minus 9 over epsilon. Then 6 epsilon equal to ايش? Almost equal to 0. So I'll just write it like that. طيب, let's now move to the next element here. How do I get this element? So I'll go up here. I'm not going to use these two. I'm going to multiply this multiplied by that. So this is equal to 9 epsilon minus 0, right? Divided by epsilon. So it's 9 epsilon divided by epsilon. So you get this will cancel with that. So you get 9. So again, epsilon multiplied by 9 minus 0 divided by epsilon. So you get 9. And this is equal to 0 like this. The sign here, what is the sign here? It's positive. What is the sign here? It's positive. How about this one? Remember, epsilon is a positive. It's a small number. It's almost 0, but from the positive side. Right? So this is also positive. لكن هذه ايش? Negative. So I already know the system is unstable. At least I have one ايش? Change in the sign. At least I have one pole. Right? So I already know at least I have one pole. طيب. Let's now continue for this one. How do I get this this element? Again, I'm going to use this multiplied by 3 minus this multiplied by this divided by this. So let's do that. So it will be minus 9 3 multiplied by minus 9 over epsilon. يعني كم? Minus 27 over epsilon minus this multiplied by that. What is this? 9 epsilon divided by this, which is minus 9 over epsilon. Again, what can I do? I can come here. Remember, 9 epsilon, it will cancel. صح? 9 epsilon هذه, it will cancel out. So what do I get? Be 0. Because epsilon is a very small number. Very small number. Multiplied by anything, it becomes 0. كأنها 0 يعني. So here what do I have? I have minus 27 over epsilon divided by minus 9 over epsilon. Actually, minus 27 can cancel with the 9 now. What do you get? You get minus 3. Right? And then minus this minus epsilon. You can actually do the calculator. So you can do it like that. Minus 27 over 001 divided by minus 9 over epsilon 0001. You get ايش? 3. Minus cancel مع minus. Epsilon cancel with the epsilon. 27 cancel with the 9. So you get ايش? 3. So this is actually ايش? Positive number. How about the element that I have here? How do I get this? It will be this multiplied by 0 minus 0. So it will be 0. 0 minus 0, 0. And this is 0. How about this element? It's 3 multiplied by 9 minus 0 divided by 3, 9. And because we have here 9, we know that our job is correct, right? We said that this has to be the same as the constant. And 9 is of course positive. Now looking at the signs here, can we now say whether the system is stable or unstable? Yes, the system is unstable. Why? Because I have two changes of the sign, from positive to negative, then from negative to positive. So I have two poles on the right hand plane. Okay, so the system is unstable. طيب, let's do another example in case number 2. Let me go back. Let us go back. You can see the here, and he's simplifying another technique. You can see the expression is a little bit complicated. So the way that I'm doing it here is whenever you can simplify, just simplify it. فاستخدم الحاسبة if you're not sure. If you have any constant multiplied by epsilon, على طول بتحول إلى 0. Because epsilon is a very small number. If you multiply a very small number by any number, it will get 0. Epsilon is infinitesimally small issue. It's extremely small. طيب let's see another case, another example on this, in the same case. So we have s to the power of 5 plus 2s4 plus 3s cube, sorry, 2s cube plus 4s square plus 11s plus 10 equal to 0. So let's solve this example. So s5, s4, s3, s2, s1, s0. So we fill these elements 1, 2, 2, 4, 11, 10. What is this element? It's 2 multiplied by 2, 4. Minus 4, 0. So this is 0. How about this element? 2 multiplied by 11, 22. Minus 10, 12. Divided by 2, 6. How about this? 2 multiplied by 0, minus 0 multiplied by 1, 0. Now instead of having 0 here, what I'm going to do? Epsilon. And epsilon is h, epsilon goes to 0 from the positive side. And now what is the element that I have here? It's epsilon multiplied by 4. So 4 epsilon minus 6 multiplied by 2, 12, divided by h, divided by epsilon. This divided by h by epsilon. Now remember, what did we say? For epsilon, what do I do with it? Becomes 0. And I have this whole thing becomes h, becomes minus 12 over epsilon. Okay, so this is simplifies as minus 12 over epsilon. But how about this element here? It will be epsilon multiplied by 10. 10 epsilon, هذا multiplied by هذا. Minus 0 multiplied by 2, so 0, divided by epsilon. So what do you get? You get 10, cancel with itself. And here 0, so below it will be always 0. Now let's move to the next element. This will be what? This will be minus 12 over epsilon multiplied by 6. So this is minus 72 over epsilon. Minus 10 multiplied by epsilon. So minus 10 epsilon. Divided by h, divided by minus 12 over epsilon. Divided by minus 12 over epsilon. Now, this we said, no, like that. This will be h, will be 0. Right? Epsilon multiplied anything, we'll make it 0. Right? معناها عندي h minus 72 divided by minus 12. Epsilon بتكنسل مع epsilon. Do it with the calculator. You can do it with the calculator as I showed you. Just look. Minus 72 over very small number. Make sure, Shabab, this very small number you use it here is the same number that you are going to use it below here. So minus 27 over epsilon divided by minus 12 over epsilon 0, 0, 0, 1. So what do you get? You get 6. Okay. ليش? Epsilon cancel epsilon, negative cancel my negative. This has gone. And 72 divided by 12 is h, is 6. How about this element? This multiplied by 0 minus 0, so it is 0. And the last element that here is equal to h, is equal to 6 multiplied by 10, 60, minus 0, divided by 6, you get h, 10. And look at the element here, it's h. What do we have up here? It's 10, right? And our steps are correct. Now look at the signs. 1 is h, it's positive. ممتاز. 2, positive. Epsilon is positive. We're going to the 0 from the right hand side, so it's positive. How about this? Negative number divided by a positive number. I'm going to get h, a very large negative number. حطه في الحاسبة لو أنت متأكد. So you get negative. Here positive. معناها ايش؟ System is ايش؟ Unstable. معناها system is unstable. And they have how many poles on the right hand plane? I have 2 poles on the right hand plane. 2 poles on the right hand plane. Because they have 2 changes in the sign. Positive to negative, negative to positive. Okay. So you have two poles on the right hand plane. Here I have a mistake, I believe. Yeah, this should be this fixed tissue. This should be ايش? This is wrong. This should be minus 12 over epsilon, not epsilon over 12. This should be minus 12 over epsilon. So we have a mistake here. So fix this one. Okay, now case 3. Case number 3 is, we'll see it now. We'll see now what case number 3. Case number 3 actually happens if an entire row, مش بس the first column is equal to 0, لا, the whole row is equal to 0. So what do we do in that case? So here we have the steps. So rather than just reading the steps, we'll dive into the example right away. And then I'm going to explain what we should do in that case. So this is the characteristic equation. Let me write it here. S to the power 5 plus 5 s to the power 4 plus 11 s cubed plus 23 s squared plus 28 s plus 12 equals to 0. So again, s5, s4, s cubed, s squared, s0. Yeah, let me just adjust it. Okay. So what are the elements that they have here? 1, 5, 11, 23, 28, then what do I put here? 12. Just go here. What is the element here? It's 55. If I multiply, you can do it with a calculator. So 5 multiplied by 11 minus 23 multiplied by 1 divided by 5. You get 6.4. Yeah, 6.4. So here we have 6.4. How about this element? I'm going to multiply this with that. أول شيء هذا مع هذا minus هذا مع. Then I'll take this with this minus this with this. So 5 multiplied by 28 minus 12 multiplied by 1, of course, divided by 5. What do you get? You get 25.6. And what do we have here? 5 multiplied by 0 minus 0, 0. Fine. What about this element? How do you get this element? It's this multiplied by this minus this multiplied by this divided by this. So it will be 6.4 multiplied by 23 minus 25.6 multiplied by 5 divided by 6.4. We get 3. So this is equal to 3. How about this element? 6.4 multiplied by 12 minus 0 divided by 6.4. So you get 12. Again, if you have 0 here, معناها this element is equal to this. Because this will cancel out and divide, it will cancel out with itself when you divide by it. And of course 0 معناها تحتها 0. How about this element? This element is equal to ايش? Yeah, 3 multiplied by 25.6 minus 3 multiplied by 25.6 minus 12 multiplied by 6.4 divided by 3. You get ايش? You get 0. So we have a 0 here. So remember, this makes an issue. Not only that, now if I go here, what do I get? 3 multiplied by 0, 0 minus 0, so it's 0. And this one is 0. So you can see the whole row is equal to 0. Now I have an issue. I cannot actually put epsilon here, because if I put epsilon, this term, what is it going to be equal to? It will be epsilon multiplied by this minus epsilon divided by epsilon. So epsilon will cancel with epsilons, and you cannot. And again, I cannot change this to epsilon and this to epsilon as well. So I cannot apply this technique. I cannot just substitute it. I just cannot substitute epsilon here. Okay. So what do we do now? What you are going to do is actually we are going to use the so-called auxiliary equation. So we are going to be using the auxiliary equation, similar to the auxiliary equations that you have seen in the engineering mathematics. So in order to fix the issue of zeros here that I have here, what am I going to do? I'll move to the one above it, the row above it here. So how do I read this row يا شباب? Look, this is equal to ايش? This is equal to 3 multiplied by ايش? By s square. Look here, if I'm going here يا شباب, what is the equation here? It is s to the power of 5 صح? Plus 5s4 plus 11 s cube صح؟ بعدين ايش؟ 23 s square بعدين 28 s بعدين 12 constant. Same thing here. This is equal to ايش؟ 3s square. So this is 3s square plus صح مش كده 0s يعني 0 بعدين ايش؟ plus 12 s0 يعني ايش؟ constant. So I put ايش؟ plus 12. Okay? So this is ايش؟ This is my auxiliary equation that I'm going to use. طيب how am I going to use it? I'm actually going to differentiate it. I'm actually going to ايش؟ differentiate it. Now take the derivative of this. What is the derivative of this? The derivative, so down here I'm going to ايش؟ take the derivative with respect to s. Derive with respect to s. So what do I get? I get 6s plus ايش؟ 0. طبعا plus 0. معناها ايش؟ معناها هذا I'm going to replace it by ايش؟ by this 6. And this 0 خلاص هو 0 replace it by 0. Again, if I have a row that all the elements are 0, what do? I go to the above row, find the auxiliary equation. How? 3s square plus 0 and خلاص يعني this. So this 3s square plus ايش 12. I'm not going to say 12s because remember الاس هنا موجودة هنا. معناها this is ايش 3s square plus 12 constant 12. Differentiate it, you get 6s plus 0. 6s. See 6s معناها الاس تاخذ ايش؟ should take 6. Okay? What constant should be 0? 0 here. Okay, so this is how I'm going from this to this by differentiation. طيب. Now what is the last element that they have here? Is going to be equal to ايش؟ 6 multiplied by 12 minus 0 divided by 6, so you get ايش؟ 12. And look here, this is the constant. It's 12, same, and that's correct. Now if I look at the signs, what do I have? Plus, 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 plus. All of them are positive. معناها ايش؟ معناها the system is stable. But because I have a row like that, whenever you have this case, it's not actually just stable. You get this case, you get 0, 0, 0. متى؟ If you have poles on the j omega axis. هنا if you get poles on the j omega axis. معناها صح ما في I don't have any poles on the right hand plane. I don't have any poles on the right hand plane. So now I have two cases. Either all the poles are on the left hand plane, or maybe some of them are here like that. In the previous two cases صح. If you don't have any negative here, any change in the signs, معناها خلاص stable. But if you have this case, if you have one row, all the elements are equal to 0, معناها ايش؟ Some of the poles are on the j omega axis. معناها ايش؟ It's actually marginally ايش؟ Marginally stable. لو كان هذا negative خلاص unstable. لكن since everything is positive معناها it's marginally stable like that. Not only that, if I want to know what is the values here, I can actually know them. Like what is the oscillation frequency? If I ask you what is the oscillation frequency, I can get it. How do I get it? From here, from the auxiliary equation. Take the auxiliary equation equal to 0 and solve it. So come down here, solve it. What is the solution to this? So 3s square plus 12 equal to 0. Move to the other side, so it becomes 3s square equal to minus 12. Divide by 3, so you get s square equal to minus 4. Take the square root, so you get s equal to plus or minus j root 2. Now what is the oscillation frequency? It is root 2. So here I have j root 2, j minus j root 2. So you have two poles on the j omega axis, as you can see here. And this is root 2 is the oscillation frequency. Okay, طيب. Now, what happens? So in the previous case, case 3, when do I get case 3? If I have root poles on the j omega axis. Like what happens if I have repeated roots, repeated poles on the j omega axis? So we said that in this case the system will be unstable, right? But this technique unfortunately it cannot detect that. يعني شوف الexample هذا احنا قلنا it's marginally stable, right? لكن if the poles here are actually repeated, then the system will be unstable. لكن التكنيك هذا ما بيقدر يعلمني. This technique is not going to tell me. يعني here we are saying that the system is marginally stable, right? But there is a chance that these poles are repeated. But unfortunately, there is no any way. I cannot know. This technique cannot tell me هل ال poles repeated or not. معناها السيستم ممكن يكون marginally stable وممكن يكون unstable. So this is the issue that we have here. You can see. With simple roots on the j omega axis, the example اللي راح, the system will have a marginally stable behavior. But if the roots are repeated, this is not the case. So repeated roots on the j omega axis will cause the system to be unstable. But unfortunately, this Routh-Harroz technique will fail to reveal to this instability. So it cannot tell us هل فعلا system is unstable or not. So this is the only issue with this technique. في حالة in the case that the poles are repeated on the j omega axis, this technique is not going to be able to reveal it. غير كذا لا خلاص it will be able to tell you. So by this we conclude this chapter. I will post some exercises on the Blackboard, like practice. You can look at them, and you have any question you can ask. So thank you very much.